here we go, tolerance. In manufacturing, the dimensions of the product might vary. This could be due to many factors, and you need to understand that tolerance is different from uncertainty. Tolerance is what the industry comes up with to put up or to account for. This is page 37, right? To account for operator error, equipment that may be faulty, limitation to the measuring device, the temperature of the environment, and many more, right? So every industry, it doesn't matter what company you work for, there's some kind of like they tolerate, they aim for something, but they will also allow for things to be off. And if you didn't do that, you would be you'd be losing a lot of money, first of all. Also, when they make something, when they produce something, a lot of companies, businesses, companies, they need to account for, hey, what if somebody leaves this thing in the garage over the winter at -40 and then it goes to +40 during the day? Is this safe? Is this packaging, is that safe? Or are we supposed to put like a disclaimer on there, like medication? Medication, you're supposed to keep it in a cool room, not too hot, definitely not freezing, right? Medication has some sort of tolerance. So a lot of, like if you have Tylenol, I don't have Tylenol on me, or Advil, it will say somewhere, store between this and this, right? And so, for example, if you have a spray cans, don't leave them in your garage over the winter, because the -40 will kind of gunk it all up and it won't work again. So every fall, I think of like bringing those down. So everything has some sort of a tolerance that it can put up with, and this is why, right? Companies or businesses would lose a lot of money if they would only accept parts that match the target value. So at KitchenCraft, for example, when I worked there with lumber, we had one dimension that was like 45 millimeters. So I would actually have this on me at all times. So I ran the machine, and the machine would rip that piece, and I would make sure it says 45 is what we were aiming for. But if it was 44, it was all right. If it was 46, it was all right. But if it was too big, or like bigger than 46 or smaller than 44, I would have to stop my machine and fix it, because there was like thousands of dollars worth of material that would be lost, right? And so that's why all industries allow for some variation, so that this is what I would like to highlight. Industries allow for some variation so that the part can still be used for its intended purpose. But the tolerance is dictated by the industry, by the field. For example, a nurse giving a shot, we talked about this. You can probably be over by a little bit and under by a little bit, but not by much, because then things can happen, right? Too much, then overdose could happen. Too little, it may not be as effective, right? When you order windows, right? Like I helped some folks install windows a couple years ago. The window's never perfect. Did you know that? It's never a perfect fit. There's always a bit of a gap. And that's there for a reason, because if they make it too big, if you order it from the factory and it's too big, it's not going to fit. It's a problem. So they make it too small, but if it's way too small, now you have a huge gap. Now you need to like rebuild your whole frame as well. So, but there's a little bit of a leeway, and they may fill that with foam, or you fill it with spacers or whatever to make it work. Same with doors, same with everything, right? Watch this. This is important here. Tolerance is the range of acceptable measurements, right? It can also be described as the measurement variation allowed so that the item is acceptable for its intended purpose. So this is kind of like a template for explaining when I ask you to explain, like, how would tolerance play a role in this scenario? When you're doing doors, for example, if the door is too small, there will be a large gap. This will allow warm air to escape and cold air to enter, and so forth. On the other hand, if it's too large, if the door is too large, it will not fit, right? It will not fit inside the frame, so that's also a problem. So tolerance tells you, hey, you can't go too small, but you can also not go too large. You have to kind of stay in between. Tolerance would have to be between the two scenarios above. Tolerance would have to be in between the two scenarios above. And then you have, now we have to ask the big question, what's the difference between uncertainty versus tolerance? Like, what's the difference? Because some students might think there is some similarities, you'll see that. But here's the biggest difference. Uncertainty that is determined by the measuring device. It's what we call the margin of error. It is set by the measuring device. That's the important part here. Uncertainty is set by the measuring device. By the limitation or by the limitation of the device. Because devices are limited. Like there's only so much you can do, and then it's got a round, right? After that, if it can't go up smaller than that. Tolerance is set by the industry. It's the range of acceptable values. It's set by the industry, and it's caused by or is due to human error, equipment malfunction, limitations on the measuring device. So that does have to do with precision. And tolerance is found here. So this is what we would call our max, our min, and this is acceptable, which is the tolerance. If your battery, I learned this the hard way, okay? I have trail cameras in the forest, and I wanted to jack up my car battery because the batteries die right away, so I wanted it there the whole season. So one of my cameras, I was actually able to take a full-on car battery and hook it up to the camera. It worked for months, no problem. My other camera, I did the same thing. I plugged it in, and I just heard like a little. I was like, oof, that's not good. So my camera is garbage now. And then I read on the bottom of the camera, oh, voltage. Like some cameras can take 12 volts, some cameras can take 6 volts. Your phones, your iPhones or whatever, most likely 5.7 volts, something like that. If you put a car battery, if you rig it up and plug it into your iPhone, you're gonna fry it, right? Unless you have an adapter that kind of brings down the voltage to yours. But every device can like take a certain amount of voltage. Batteries, this one says 9 volts. It probably is 9 when you buy it brand new, but as you start using it, it's gonna come down to a point where your device will no longer work. So your device is made, whatever has this battery will work probably, the device will probably be made to withstand 10 volts to like 8 volts. And once it goes below 8, it will stop working on you, probably, okay? So I can measure what the voltage is on that. It's an old battery, so it's probably 7 or less than that. So let's do some math here. Let's go to 38. So this is where it gets a little bit more, where you can actually do some work and practice this, okay? I know this is dry. I'm trying to make it fun. I'm not very good at making this fun, but let's just get through it, okay? You need to know 4 things, right? When you're stating your tolerance, you want to know the maximum, the largest measurement acceptable, the minimum, which is the smallest measurement acceptable, the nominal. What is the nominal? This is what you need to make sure you understand. The nominal is the target value. Ideally, you would want all parts to measure this, okay? Tolerance is the range / variation allowed, okay? So here you have a visual that I tried to come up with where I think I'm just going to add this here, tolerance, anything in here is acceptable. Anything that's in between this is acceptable. But if you're below the lowest value, you're not acceptable anymore. If that part is bigger than the maximum, right, then obviously it wouldn't be acceptable. So anything in between here is acceptable. So that's your, I think what I wouldn't mind you do is on your study sheet, have these ones, like have just a small diagram, maybe just go max to min and just kind of have like tolerance like this. Like I would just have this little piece on my study sheet because that is going to help you a lot when I'm asking you questions regarding tolerance. And watch this, tolerance is, how do you find what tolerance is, what that difference is? You just go max subtract min. So whatever this number is down here, right? So you go max minus min gives you the tolerance. That's how you find it. How do you find the max? Well, if you have the min, right, if you have the lowest number, you just add the tolerance and then you get the max. Or if you want the min, you take the max, subtract the tolerance to go back to the min, right? So there's a tolerance of separation between the max and the min. Okay, so we're gonna practice this. There are 4 ways that tolerance can be expressed. And I need you to have these 4 ways on your study sheet. So I'm going to highlight the things that need to be on your study sheet. Okay, so I'm going to say this part. And I'm going to say this for sure. Right, study sheet. I'm going to say study sheet on this. Okay, so you know, hey, add those 4 ways to state your tolerance on your study sheet. Watch what it says here. I'm going to get to the math in a bit, okay? So just follow, please. If given 1, you can rewrite them into the other 3 forms. That is very important for you to know. I should be able to just give you one of these formats and you can branch off into the other 3. Okay. I need you to pay attention to this because this is such an easy mark if you just know what you're supposed to do. The nominal, the target, guys, the target measurement is always the first big number. So, for example, here, this number will be my nominal. What about this one, Mr. Dirksen? That's mumbo jumbo, right? Oh, that big number there is going to be what the target is. That's our target. That's what we want. Ideally, all pieces are exactly that. This one here, that one right there is my nominal. And then we have a problem, Houston. What about that last one? There's no one big number, Mr. Dirksen, so what do we do there? The province says that usually there you will not have to state the nominal. But if they do ask you for it, it's going to be the average of these 2. So watch this. I'm going to add this here for you. Nominal. Nominal would be max plus min divided by 2. That's how you find it, right? So that's how you will insert that. So you can't just read a number and say, oh, it's 15 or 12. It's not. It's in between. It's in between. So we'll do that in a bit. You don't have, so have the formula just in case. but you basically find the average of the two. I'll just say here, nominal is not given. So you have to calculate. Can you see that? It's very small right here. Nominal is not given. You have to calculate it in that instance. Here, I hope you remember average. Average is just add everything up and divide it by the number of values you're adding. And so because it's always going to be two values, that's max plus min divided by 2. So let's have fun here. You ready for fun? Yay! So why am I doing this here, guys? Why am I doing this? Because if you're able to read any format that I give you and fill in these 4 things, this is kind of like an inventory, you will be able to rewrite it in whichever form you want to. So nominal here, let's fill that in, 250 mLs. What's my tolerance? Well, watch this, guys. You should be able to read this, go back to your study sheet, and be like, oh, this one looks like this format right here. And I know what's inside the brackets is my tolerance. So tolerance in this case is 10 mLs. And what's the min and the max in this case? Well, the max is exactly, you're just going to follow this formula. 250 plus 5. Why 5? Well, this half of 10 is 5, right? So 250 plus 5 gives you the maximum allowed measurement. And the minimum is 250 minus 5, which is 245. Now I need you to see the connections. I need you to see the connection. Can you tell that the tolerance is 10 just by looking at these two? You should be able to see, oh yeah, that's 10. There's a 10 milliliter difference, so that's my tolerance. So things should jive. It's like, oh, wait a minute, let's try this. Mr. Dirksen told me to get the max, I just go min plus tolerance. Okay, so if I took my minimum and I added the tolerance to it, would I get 255? And you're saved by the bell. Anyways,